This morning's talk, I'm going to try to do something a little more conversational, a little more laid back. I'm the opening act for Heidi Ream, which is pretty cool, so I'm going to get everybody in a good mood and laughing and just sort of chatty for the rest of the day. We really want this to be about future directions, thinking about next steps. You're all experts in NGS analysis and variant and gene interpretation now, so we want to have some good conversation. And I will be talking about the use of clinical information and data analysis with my subtitle, "It's not just what you say, it's how you say it that matters." So before I start, I have no conflict of interest to disclose. For the NSGC CEU requirements, I wanted to keep to my learning objectives. So I will be describing the role of clinical information in the gene and variant interpretation process. I will compare various gene and phenotype ontologies and examine the role of patient-reported clinical information in large-scale genomics. So it's morning. Hopefully you've all had some coffee. Let's have a little conversation. So we're going to start with a direct poll. So the link that is down here, all of you can pick up your phone, your computer, whatever you have available, and we'll start with a few questions. So, oh, sorry, that would make way more useful for all of you. There we go. When everybody is looking back up at me, then I will go away from this screen. All right, can I go to the next screen now? No? Okay. I also realized, all right, Stephen, you're in charge of giving me timing when I'm going too long. Thank you. Now may I go forward? Okay. Great. So the first question is, for those of you in the room, do you order clinical or research genetic testing? Yes or no? It's closed? Ah, they're killing me. Paused. Let's try that again. Oh, and it went back.
Push the square stop button, and then you can go back and restart it.
Thank you. There we go. Now can you all go? All right. All right. So we're between 40 and 50% of you do order genetic testing, either clinical or research. Great. So for a couple questions, hang in there for those of you who don't. I'm going to ask the people who do order clinical or research genetic testing, on average, how much or what clinical information do you provide when you order testing? Do you provide high-level diagnosis only? Do you provide high-level diagnosis and family history? As much possible information as I can fit on a form, or I do not provide any clinical or family history whatsoever. I can tell there's a lot of genetic counselors in the room. Great. Okay, so it sounds like people do try to provide as much information as possible. Sometimes that's as much medical information as you want. Other times it's simply a high-level diagnosis, but I'm happy to see that family history is often included. All right. So when you provide this information, what is the format that you typically provide this in? Is it either written or printed on a piece of paper? Do you provide it in electronic form? So this could be through a JSON file, an XML, CSV, through an online ordering portal, or do you just have to go with whatever it is that the lab requests? Okay. Great, that is helpful. That question is more for me as we move along in this talk. But it does sound like people are willing to give either. A few people are still holding strong to the printed side of things. All right, now it is back to the whole group. So for those of you who do this in your regular job, you do gene triaging and curation, and then I'll also be asking about variant interpretation. How much you find just the phenotype? So we're going to separate out phenotype and family history for this question. How many of you found the phenotype information useful for the gene triaging and curation process? All right, that's positive. That's good. Okay. All right. So how many found, oh, sorry, I swapped these a little bit. Bear with me, I'm trying to keep you all awake, I guess. How many of you found the family history data useful during the variant assessment process? All right. Anybody who's close to the sides or want to comment on why, in this case, it was only somewhat helpful as opposed to extremely helpful? Just sort of a ranking. Okay. So how many found the family history information during the gene triaging and curation process? All right. And then, oh, so this one was supposed to be gene. My apologies. I added in the family history stuff last minute. So we'll say in this case, how many of you found the family history information? Well, you know, we'll kind of skip this. I think we're actually knowing the general thing, so I don't want to confuse everybody too much. All right, great. So the point of this was to show that there is a reason why we ask for clinical information when we're doing genetic testing, and that I think now that all of you have gone through this experience, you understand the importance of having that information. So what I will be focusing on for the remainder of my talk is instead of just talking about, you know, we want this information, we need this information, please give it to us, I want to take a slightly different approach to this conversation and talk about the sources and the structure of the clinical information that were provided, and then also how those sources and structure play into the role of clinical data during prioritization and data sharing. So we have a lot of different sources of clinical data. I'm also going to try to come away from the podium to make everybody a little more chatty, ideally. We'll see if that works. I think this buzzer or laser is a little easier for you all to see. So over here is talking about the medical sources of information. So we have the lovely computer, which is to represent electronic medical records, electronic health records. Traditionally, this was a great step forward. I do remember during my clinical rotations going back to back, one hospital where it was a completely paper chart system. I would sit in the back room with literal boxes of charts, going through, reading them, trying to summarize for the clinician, terrified because I was a new student, being able to summarize all this. Did I miss a chart? Is this a shadow chart? How do I get to it? My next rotation, they had moved over to an EHR. I was like, I got this.
Is your mic on?
Oh, no. Is it not? No, it's not. Okay. Now I can, maybe this recording, other people won't find it as useful, but that's okay. So anyway, so as I was saying, moving away from the paper-based and moving to electronic records was a huge improvement. However, these are now really fancy electronic silos because in order to get the information out of these EHRs and send them to another institution, often what we have to do is go right back to printing them all out and putting them in a box and sending them to someplace. Sometimes a lot of you lovely people in this room type up a great summary and can send that along to us. Often, again, it can get printed out and sent to us through sort of email or things like that. But if we want this to ever become a coded phenotype, something that lives within a system that could be used for interpretation or prioritization, at some point, some of you in this room, including myself, have to sit down to a computer with a buddy and type it into a system to get it coded. Obviously, that is not the ideal situation. Now, we do have some new systems that are emerging called next-generation phenotyping. It's a new term I've heard about. Sounds very fancy. So there's a couple different ways that it's being used. There are certain technologies and softwares that are taking pictures of people's faces and turning that automatically into codes. There are other softwares that are starting to be developed to go into medical records and pull out key information. So what this term next-generation phenotyping, I think, really means at the core is trying to replace this process of manual entry, which I think a lot of people are on board for, but obviously it's in its infancy. A lot of studies need to be done about its accuracy, but there are some sort of breadcrumbs of things starting to happen. And then down here, which I'm blocking for some of you, so I'll move off to the side, are more about patient portals. So we will hear about Genome Connect from Heidi. Patient portals are becoming a huge player in this space. There's companies that are offering this to patient registries. Patients are freely putting their information out on websites. They're participating in it. They want their data out there, and they want it to come from their voice. And so one challenge that we're facing is how do we bring together all of these different sources to have it in one location that it merges together. We know the source, we know who provided it, we know where it came from, but can have it in one system together in one record. And that how is a real question. If anybody knows the answer, we would love to hear it. It's a challenge we're facing within our own group as we are trying to expand getting this information into our system in a digestible and useful way, both for the genetic counselors that work on our team, but also the analysts who want to use this during prioritization and variant review. I will pause to see if anybody gets up to the mic if they have a great, wonderful answer we haven't heard about. Okay, I didn't think so. All right, so if we want data, it needs structure. Data and structure go hand in hand. If we just have a list of classifications or a list of information, we just basically are at a printed state that we were at before. So that's the place for ontologies. So I've never had to actually define ontology with an ontologist in the room, so I'm going to do my best to not insult Melissa. But ontology are either concepts or classifications, not classifications, concepts or ideas or themes and categories, and the ontology is showing the relationship between these. So for genetics and genomics, but specifically for clinical information, you could think of it as breaking down a human being, turning it into muscle cells, and then talking about mitochondria, talking about the abnormality of form, the abnormality of function. You can talk about with your heart, whether it's the fetal heart that we're talking about, the morphology, the physiology, and you break it down and it becomes this very large network where any single term that is used can be mapped back to its original source. So the great news is there's a lot of ontologies. We use them all the time. We might not even know that we're using ontologies. But there is a spectrum of ontologies. There's a spectrum of granularity and detail given to them. And the key part that I will focus on for the remainder of this section is really talking about the difference between the disease ontologies and then the phenotype ontologies. So we probably have all heard of OMIM. I don't always feel that's a true ontology. Sometimes I call it my non-ontology that I have to use for certain things, but it is technically thought of by many sites as an ontology in our field. There's also something called MedGen, Orphanet, SNOMED, CT, but then these are all diseases. So these high-arching disease names that we give to patients like Smith-Magenis, Marfan syndrome, Noonan syndrome. It's this high-level diagnosis. Underneath that, or above that in this, is the phenotypes. That's what the patient's actually presenting with. And these can sometimes blur into each other, but for the sake of ontologies, they have to be broken out. And so for a long time working with Heidi, one of my jobs was going through all the different diseases that we had in our database. And it was my job to decide, is this a disease or is this a phenotype? I always thought this would be a really easy exercise until I was about 1,000 terms in, and I would just start to be like, I have no idea anymore. I can't figure it out. And because a lot of them sometimes can be both, it just depends. Dilated cardiomyopathy as part of a larger disease is heart failure and might actually be a phenotype of a larger disease. In other places, it's the primary diagnosis. The other thing about this is there is a role for both. So phenotypes are really helpful in knowing exactly what the patient is presenting with. But the disease can give us a lot of context and information. However, when you separate them, diseases do not always equal phenotypes, and phenotypes don't always equal diseases. So for example, if you just say to me somebody has Fragile X syndrome, I say, okay, well, are they male? Are they female? Is this the Fragile X ovarian failure syndrome? Is this a young boy who's being diagnosed with intellectual disability? Similarly, if you just tell me that somebody has abnormal facial features, some behavioral problems, and intellectual disability, I might not know, and more importantly, my computer system that's doing ranking might not know that we're talking about Fragile X. So there is a role for both, which is why in our group, we don't have a single source of ontology yet. So for our group, as many of you saw in Seeker yesterday, we do have a phenotypes location where we enter in, or our collaborators enter in, all the different phenotypes. We also have a coded phenotype. You guys did not have access to this yesterday. This is a staff-only field that I often am the one entering it in with the help of our analysts. I do try to closely mimic this to the monarch ontology, which Melissa will be talking about later today. It's a master ontology that I don't always have to care whether my exact term fits into one ontology versus the other. It brings them all together and gives me more flexibility and options of what I want to have as that coded phenotype. But then we also have this post-discovery OMIM ID for when we discover known genes for phenotype. And this is just because this is a requirement of our NIH progress reporting. I can't get around it. I have to use it. So I have to store it somewhere. And these three things live individually. I can't merge them right now. And so we are stuck storing phenotype data in 3 and sometimes even more than that locations within our system. And we're trying to be progressive about this, and we're still stuck with this model. So this is the model we are in, but the reason we're working on this and the reason that we want to push things forward is because there is a role for clinical information and family information in prioritizing genes and diseases. So I do recognize that there's a lot of different ways to talk about this, and I do have minimal amount of time to cover it. So I'm just going to have sort of a global caveat that for known genes for phenotype and secondary findings, I completely recognize that knowing the patient's presentation for whatever disease they've come in for is independent of secondary findings, are independent of whether you find something and you rank it for variant prioritization based on very well-known, very well-curated genes where we know what we're talking about. So I'm not going to talk about that today. What I'm going to talk about is gene discovery and trying to flush out those sort of gray area genes and variants that we're trying to figure out what's going on here and what's the role for clinical and family history data in that. So I know that all of you did a lot of searching yesterday where you, one of your main searches was based off of family history. And from taking the survey, it sounds like all of you completely recognize the need for understanding what's the family history information in order to run the searches that you need to run to find an answer. Knowing whether there's somebody else mildly affected, knowing whether or not that child is the only one in the entire family with any of these phenotypes or diseases makes a difference in how you run your search. So I think you all got to enjoy this yesterday, where our expectation is that you're going to hit the search button, and here I am, pick me, I'm the gene you want to read about. Well, reality is you spend a lot of time reading about a lot of things, and this one made me laugh the most because I feel like this is what I always do, where it's like make sure to spend 5 to 10 minutes reading about me and then realizing you didn't need to read about me whatsoever. So one of the main things that we can do after we look at functional data, after we look at these predictions, is we can start to talk about how clinical data relates into this. So there are new tools that are coming out. Some of these are not new, but we'll just say ballpark 5 years, we're talking new, where they are starting to include in the functional data scores some of the phenotype data that you can put in there. The caveat is, in order to use that data, it needs to be coded. It needs to be in HPO terms. It needs to be in the ontology that this picks, or one of these picks, in order for it to be used. So it's this chicken and egg, where yes, we could start to make these better, but in order to make these better, we have to get more clinical data. In order to get people to appreciate the use of clinical data, we need to have a reason and a score. So this is just to show we need to work this together because we need a trusted data set, we need to prove things, so we need to start collecting coded phenotypes now and start to use them in a useful way. The other thing I will say, there is a paper, which I've cited down here, that has shown that the scores that use coded phenotypes do perform better than the ones that do not in triaging, but that we need more studies in general that assess these on different data sets and put them through better true scientific comparisons to see how these tools work together, or which one works better, and why they work better. Is there an ontology that works better? Is there an underlying mathematical problem that works better? And we need to figure these things out. So now moving on to the role in data sharing. So how am I doing on time? Can anybody?
9:25.
Oh, I'm actually really ahead of time. All right, great. We can have a conversation at the end, so I hope I'll have lots of questions. So I don't want to steal too much from Heidi, and I don't think I ever could, but I do want to talk a little bit about the role of coded phenotypes in data sharing. So within data sharing, we've done a lot to move forward the data sharing of variant information, of gene information, but there is still this gap with clinical information. So we sometimes can provide high-level phenotypes and things like ClinVar. However, even I struggle sometimes when I'm filling in our ClinVar submissions because, again, I have to give this high-level diagnosis, and I can provide the phenotype, but for really rare disease, at what point am I crossing a line? Does it matter if I'm crossing a line? I'm not really sure. It's me with my computer. I can talk to Heidi. I can talk to Daniel. I can talk to Stephen. But nobody really always knows where that line is and how much we can share and what is useful versus what is ever maybe giving away some privacy that we're not aware of. But that being said, when it's talking about sharing data between collaborators, I have the wonderful task of triaging all of our Matchmaker and Matchbox emails that come into the Center for Mendelian Genomics. And I just wanted to point out that this is just a subset. I picked 4 random emails out of the hundreds we've received and pulled them up, and every single one of them, within the first paragraph or first couple sentences, they explain their patient's phenotype and they ask for our patient's phenotype. Every single time, hands down. Maybe there's 1 or 2 that don't, but they are outliers. This is information that people want to know. This is what they want to compare. We have the same gene. Does it match the phenotype? So whether people say this information is not helpful or not, I think the proof is in the pudding, that the reality is we go into a data sharing site and we want to know what does the patient present with, because it does help with the triaging. The level and extent is certainly different based off the context. Is it a known gene? Do we feel like this gene has functional reasons? We're not really considering it, so even if the phenotype matches, reality is we're going to toss it away for other reasons. There are obviously different flavors of this and colors of this, but at the end of the day, most people want to know phenotype, even if it's just helping for context reasons. And right now, this is being done. Matchbox does share our HPO terms externally, but there are limitations on other people being able to digest that information and use it. And so there's still improvements to be made. And I think a lot of people just end up going to these sort of more conversational based, can we talk about this? Can we kind of explore it? A lot of times it's because if you just look one-to-one where somebody says, I have tetralogy of Fallot, well, I have a congenital heart defect. Are those the same thing? Can we count those? What's your congenital heart defect? And so sometimes there just needs to be more conversation rather than just looking straight codes. This last slide is not just to prove my purpose to Heidi and Daniel, though I did use it a little bit for that too. It's meant to show that when we are putting our data into various data sharing sites, there's a lot of manual process that has to happen, which are these lovely rainbow lines in the middle. But what I want to point out to all of you is the craziest chaos happens in these 3 not shared phenotypes that don't overlap. In each system that we send to, I need to send a different phenotype in a different form, in a different way, in a different context. I'm allowed to share a certain level here, a certain level there, and I spend a lot of time trying to figure out what's the right one for each thing. And every time I do this activity, I know there is a better way, and I know that there are hundreds of other people around the world doing what I'm doing, and it drives me insane because I feel your pain. So for all of you who have to do this, we are trying to move forward. There are answers, there are solutions, but it has to happen in a thoughtful and patterned way so that we don't just recreate a larger problem. So with that, I gave you all a little to think about over your morning coffee. We are a little ahead of schedule, so I'll put up my conclusions, but I do want to hear from everybody about sort of how are these themes and ideas playing out in their sites. So I know that we have a lot of clinical people, a lot of research people. I know that we have some of our own collaborators who we are starting to move towards exchanging phenotypes files through JSON uploads. I'm discovering even the difficulties and nuances with those and matching IDs and things like that. So it's never a simple process. So I also do want to thank all of our collaborators who go through this process of entering data for us. It is really useful, and we do want to streamline that process even more. So this is just my opportunity to all of you who sit at that desk and enter the data into a coded form. We promise to put it to use, and we promise we are trying to make it as impactful as possible so it doesn't go unappreciated by all of us. But with that, does anybody have any questions, any statements, any declarations of knowledge that I'm not aware of? And just a reminder to use the mics. Or does everybody want a few minutes for more coffee?
Hello,
Hi.
I'm Elizabeth. I'm a genetic counselor at Brigham and Women's Hospital. So I order a lot of genetic testing in a clinical capacity. And I definitely try to be thoughtful in the records and medical information and obviously family history that I send to labs. I think one factor that wasn't touched on that I try to consider is insurance as well.
Yeah.
And providing records that would be helpful and, kind of illustrate the key elements of the phenotype and be very descriptive with the paperwork and, writing down everything. But I think also just making sure that there's medical documentation of, benefits of this or the severe phenotype and how this could benefit. So just a comment there, I guess.
No, I think that's a great point, and it's one luxury I've had throughout my career is that I haven't had to deal with insurance companies nearly as much as the rest of you, but that is a great point that probably could be, I could fill out my initial slide deck that has, it only had 3 corners. I could probably put a 4th corner that has just the insurance companies and how we connect information to them, and that is a great point that a lot of this information as we code it is lost, and that's the patient perspective and patient impact of all of these things. Just saying something is severe doesn't capture what these families are going through, and trying to have a way of including that information and that detail is a whole other spectrum of this that frankly is a lot, but I do think genetic counselors will have a big piece to play in that. Does anybody else have any?
Hi, thank you for talk this morning. I'm curious to know how this impacts private industry, if you have any knowledge around that, if that's holding back any kind of research or drug development.
I can give you my best answer for how this impacts is that I do think there is private industry playing out in a lot of these spaces. There's private industry getting into the patient portals quite a bit and trying to bring the patient information into their systems to connect that. There's a lot of use for that data. I could have a whole other talk on that, but I will stay out of that swamp, if you will, of detail. But there's players trying to get into this space to try to kind of bring everything to their database or get things into their database. There's also influence on genetic testing labs to move to more of a portal-based order entry system, which obviously rubs up against the sort of centralized lab within a hospital having to have all the systems ordered through them, or all the testing ordered through them, through their own systems. And so often what happens with these different challenge is that a lot of people can take a lot of approaches, and for a while it can just become a little bit more of a hot mess, to be honest. And sometimes it can lead to a lot of systems, but those systems don't necessarily talk to each other, and so paper becomes the in-between. And so I think with the slant towards private industry, a lot of times that there are business opportunities to be found here, but everybody has to make themselves a little unique and a little different, and sometimes that can increase some of the challenges. But I think that they also are able to use newer technologies and advance things faster, so there are going to be steps forward coming from private industry that hands might be tied because of academic or hospital-based bureaucracy or reasons why we have to stick with the systems we have to use for a while. Does that answer your question? Or, okay. Does anybody else have any questions? All right.